can divide the water column into density zones. The surface zone, which is the upper layer of the ocean containing at least the least dense water. It's about 2% of the total ocean volume. The pycnocline, the zone in which density increases with depth. It's about 18% of all ocean water. And the deep zone, where there's very little change in density with increasing depth. And it's about 80% of the ocean water. The thermocline, which is the middle layer in which the temperature is changing rapidly with depth. Cline means change, thermo means temperature. It is different in all areas or latitudes. That's what the graph is showing. Over here in the blue, we have the thermocline or the temperature change along depth in the polar ocean. Notice that there is no thermocline. It's a straight line. The temperature in the surface, it's very close to the temperature at the bottom. In tropical waters, however, the surface temperature is much different than the temperature in the bottom. And so the change in the temperature, the slope that you see here in the halfway through the water column is what we call the thermocline, the change in temperature. The green line represents the thermocline in temperate regions. You can see that the very surface of the ocean has even temperature. It doesn't change. This is what we call the mixed layer. At a certain depth, there's no more mixed layer, and the temperature starts to drop until it becomes constant. The region where the temperature is changing is referred to the thermocline. And then we have the halocline. The halocline is the middle layer in which salinity changes with depth. Again, cline is change, halo is salt. It develops in shallow water near rivers because you have that fresh water finding the salty ocean water. Here's a vertical density profile compared with the halocline. You can see that the region of the halocline is the same region where you have the pycnocline. So the halocline always corresponds to the pycnocline.